I don't know. All right, welcome back, everybody. Today is, I lost everything. Weird. I can't, that's odd, right? You guys see there's no time or anything on my screen anymore?
Yeah.
What?
Everything's gone. It's broken. Oh no, we can't run math today.
That is so weird.
Why is it yellow?
Oh no, it's right here.
No, like notice there's no time or windows or anything.
Was
Yo,
there a power outage at school this morning?
I did not have a power outage. I heard, yep, there was one at my house too because Mrs. Holloway put in a loaf of sourdough right before the power outage and we don't know how it turned out yet. All right, here we go. What was this called?
That's called a global maximum.
Good. It's also the local. This is called,
Local and global minimum.
is it the global min though, Tristan?
Oh no, it's not.
It's a local min. What's this?
Local max.
Now, we made the comment the other day about, I should probably get a calc book in front of me. We made a comment about something happens with respect to the calculus at those points. What's, maybe. This is a continuous function. What's the derivative right here? 0. What's the derivative here?
0.
And the derivative here?
Nothing.
I like undefined because I think that you might have had the right thing, Lily, but I would argue that nothing could be interpreted as 0. It depends on how you're thinking. But okay, so here we go. I think, did we write a theorem before this or after this? Was it the extreme value theorem? Okay, I'm cool with that. So, here we go. We get a theorem right off the bat today. And all of a sudden we're going to see where the calculus starts coming into play. So we're still in 4.2. We're going to jump right in with a theorem. We already did the extreme value theorem, right? Okay, on a closed interval, if a function is continuous, I guarantee it has an absolute max and an absolute min. Okay, that's the extreme value theorem. More so, we have the following, this is a stupid name for a theorem, but conditions for local extrema. It just doesn't really sound like a theorem. Yeah. So your book actually has conditions for local maximum or a local minimum, but here we go. Okay. Here it is. Tristan, you're probably going to need some notes because we're going to do a bunch of problems today. All right. If a function f, and I'm just going to shorthand with func, f has a local extrema at x equals c. So guarantee, if I have a function f and I'm going to make the claim that it's like a nice function f, that it has a local extrema at this value, then, and this is kind of like the comment we left, what should I find is true about f prime of c? Think about a nice smooth curve that has a max in it. What is f prime at the very top of that thing? 0. Or think of an absolute value, like this, maybe a negative absolute value. Obviously the max is up here. What's the derivative here? Undefined. Okay. I'm going to say f prime of c dne. Okay. Now I'm going to even go a little bit further in here. I'm just going to sneak in one more vocab. And this within this as well. The points x equals c where this occurs. And I want to make sure we're clear with the language. I'm trying to get through our notes without having to be like crazy wordy about it. The points where these things occur. When I say when this occurs, what am I referring to? So f prime is 0 or undefined. Yep, absolutely. The point x equals c where this occurs is called and here's our vocab, critical number. Now, we will be using critical numbers extensively as we go through stuff. Hey, did Sam make it out this morning? Anybody talk to him yet? They canceled the afternoon flight already. He could be to school. Oh. Although a plane did land 20 minutes ago.
He said he saw Zeke.
Oh, cool. Did he say how handsome he was? He better have. All right. What do you call the point x equals c where the derivative is 0 undefined? Critical number. It is imperative that we understand and use this language constantly. Now, we're going to commit some time to just working on how would one go about finding a critical number. Anybody need more time to write, Tristan?
I need to put
Okay.
a critical number.
Happening in here. Let's do some examples. Example. All I want us to do on this problem is find critical numbers. That's it. All right. So let's go through a few of these guys. Oh, that's a neat problem. Love it. All right, for our first one, f of x is equal to, we get a product here, it's x minus 1 squared times x plus 1 cubed. You think it's bright enough that I can turn the lights off? Okay, so definitely for Jadri it is. Because her paper lights itself up. I'm more concerned about this side of the room. If it's too dark, tell me. I'll turn the light back on. Can you guys all see?
Yeah.
Okay. All right. We're finding a critical number. Now, when you guys went through, like, obviously I was here for the first month. When you guys did all the derivative stuff throughout chapters 2 and 3, how much emphasis was placed on the algebra recall? Like, how much did you guys simplify stuff, I guess? Okay. So we're going to. And we're going to, no, see, you say that, but we're going to, like, in this problem, we'll see why is it important that we do. Now, yes. Cool glasses. I haven't seen those. I like them. All right. We are going to have to do some simplifying stuff. I need you guys to make sure you're really vocal. If there's something that I do that you don't understand, ask about it right away. We'll see old algebra ideas, but maybe we haven't thought about them for a while. So I'm trying to find the critical numbers. How did we define a critical number a moment ago? Yeah, perfect. Where f prime of x is 0 where it's undefined. Right now I have a function f. If I want to find the critical numbers, I need its what? The derivative equal to 0. So let's find the derivative first. And here's where all of our algebra is going to happen. Now, is the derivative itself hard? No. I don't think so, really. We're back to good news. We are back to taking the derivative with respect to which variable? X. There's no implicit stuff going on right now. Okay. How do you find the derivative of these guys? What's the rule? First. So here's the first. It's x minus 1 squared times, what's the derivative of the second? Okay, can I do, it's 3 times x plus 1 squared, right? 3 x plus 1 squared. And then I'd write times the derivative of the inside, but it's just 1. So now all I did was, instead of writing a 3 right here, I just moved it out front. Everybody cool with first times the derivative of the second here? Plus, what's the second function? X plus 1 cubed. Notice the awkward space because I know that the derivative of the first is 2 out in front. X minus 1 to the first power. Okay. Right now, we see the importance of knowing a little bit of algebra. Was that derivative like crazy hard to find? I hope not. If I said equals 0, is that an easy problem to solve? No. Not particularly. But I bet it really is an easy problem, or at least easier than it appears right now, if we can do a little bit of simplifying. So, let's do that simplification real quick. Are there any number... I'm going to rephrase a couple things. How many terms do you see on the board? Is that a binomial, a trinomial, a sexnomial? What do you want to call it? Why try? Okay, I would be real careful. These are all stuck together by multiplication, right? Right now, this is a single term. These are all stuck together by multiplication. It's a binomial, the way it's written right now. If we expanded everything out, it'd be gigantic. I think it'd be a 4th degree polynomial, eventually.
Also, it's a 3rd degree.
I think it's actually a 4th degree, because I see these powers of x would be x to the 4th. But Right now I see two terms. First term, second term. So let's just try to clean this guy up with factoring. I'll even right away set it equal to 0 since we're looking for critical numbers. Do you see any just constants that can be factored out of each of these? Okay. So constants, I don't see any. But you guys did see other stuff. How many x minus 1s does this one have? How many does this one have? I can only factor out one of them. Okay. I'm going to factor out, and it's going to look ugly for a second, but I'm going to factor out x minus 1. Is there anything else that I can factor out? Okay, x plus 1. How many x plus 1s in this?
2.
How many here? So I'm going to factor out the least power is what this is called. I can pull out a square, right? When I pull those things out, let's just see what it leaves behind. In this expression, I was left with a 3 and a what? 3 and x minus 1. That's it. Plus, what remained here? There was a 2 and an x plus 1, right? Okay. Was any of the algebra stuff did I lose anybody in that step? All right, let's just clean it up a little bit. I'm not going to touch these. I don't really need the brackets around them either since they're just multiplying. So I'm going to lose my brackets. X minus 1, x plus 1 squared. Then let's just clean up what's in here. That's 3x plus 2x. Would give me a 5x. I'm just distributing here, and I'm just doing it 3x and 2x. And then I get a negative 3 and a plus 2. Minus 1. Okay. Depending on how comfortable you are with your calculators, for me, I might legitimately be able to do this algebra faster than I could to type it into my calculator and ask it to simplify. I'm way more certain I'm going to make less mistakes if I just do it by hand. Your calculator could do it. Right now we have our derivative in probably the most simplified you've gotten in this year, right? You don't always simplify them like this. But from it, can you tell me what values of x make this 0?
1.
Okay, more so, what do we call them? The roots of the derivative. What did you call it where the derivative is 0 or it's undefined? Check it out. Be really specific. Crit numbers. That's what we're asked to find. That's what we're finding. It happens at x equals, you guys told me the first one was 1. Where was the second one? Negative 1. And I'm just going to think to myself, how many times did it show up? 2. Okay. And the last one? 1/5. There were 3 critical numbers. I'm sorry? Okay. Now, what do you think these critical numbers might mean?
The 0.
Of the derivative, I would agree. Do you think it guarantees that they are? Don't draw this, I just want to think about this. This function right here. I gotta do it. I always struggle to draw these, I can't draw them very well. Okay. Something like this. What do you think the derivative would be right here? 0, right?
Yeah.
Would it be a max? No. Okay, let's do another one. Has everybody in here seen that movie? That blows my mind.
Let's watch it as a class.
Not a chance. Not a chance. All right, here we go. I want you guys to do another one for me, and then we're going to make sure we can see where these things happen. Okay, critical numbers of the following. This is for you guys. You get to play the algebra game. I want f of x is equal to x cubed plus 12x minus 24. Okay, I'm going to give you a second. I'm going to give you a little head start. Find me the critical numbers of this guy. Okay, if we got to this point, what do you find? Ooh, is it?
No.
Is it?
Maybe. No, because it's
Squares and it's positive.
Yeah, x squared plus 4 equals 0 would give me x squared equals negative 4. Not a chance in the real world or real numbers.
Wait, isn't that
You're trying to think of a difference of squares,
Oh, never mind, never mind.
but it's a sum.
I just did it differently. There's no. Oh, so it's undefined.
Because negative
Yeah,
3
careful. No, also not undefined.
What?
Not undefined.
Wait, why does it have
So
no
I mean, it's
critical
just
numbers?
like a line.
Can you ever make x squared plus 4 equal to 0?
4.
Which is
Oh,
critical
no, you
numbers.
can't.
What does that look like in
Okay.
the graph? Is that just
Something that doesn't have a max or a min. A straight line.
a straight line? Yeah.
Or if we want to look, I can't look at it here for some reason. Desmos. Once this loads, will somebody read me the function that we just graphed? Because I lost it.
It's 3 times.
Why is it doing this? What's F what is full screen? F10? F12? F11. I don't know what's going on here. Y equals, what was it?
3x
The original though, right?
Oh.
X squared plus 12x squared.
Does that thing have any maximum or minimum? Doesn't look like it. It's just barely too much.
Why are we trying to find the original equation?
Because there's a link between our original equation and its derivative. And we're about to see what that link is.
Okay.
Okay. Great question. But I want to look at the original because if there was a critical number, I'd expect to see it on my graph of f. Okay. Everybody okay with the act of just simply finding critical numbers? You set the what equal to 0? F prime of x, or the derivative. Okay. Here we go. New little topic within this section. I want to discuss how does one actually go about finding absolute extrema. Finding, and I'm just going to say extrema. I'm not going to bother saying absolute. We'll hit them both in here. Okay. For each of the following, we get some steps, we get some theorems and stuff. But here's kind of what I want to go through. I want us to let f be continuous. Let f be a continuous function on the interval a to b, the closed interval more specifically. Okay. I can draw it nicely. Typically a polynomial, but it won't always be a polynomial. It depends on what interval I'm working on. Here we go. We're going to get our first theorem. And here it is, theorem locating extreme values. Locating extreme values. And I really want to pick apart the language here because they do kind of get muddled together a little bit. We have an extreme value theorem already. What did the extreme value theorem tell us? EVT is how I would shorthand that. The extreme value theorem says that, hey, if you have a function that's continuous on a closed interval, what must exist? Absolute mins and absolute maxes. What do you think is going to be different about this theorem instead? Close. What changes about this? Instead of just the extreme value theorem, it's a locating extreme values theorem.
Finding.
Yeah, let's actually find them. Only difference. Extreme value theorem says, hey, there are maxes and mins. This one says, here's how you find them. Okay, here we go. The function f will have extreme values at one of two places. So I'm going to decide if we want to write 2 or 3, whatever one you think makes more sense language-wise. I'm just going to leave this blank for right now, okay? Just a number. It's going to be 2 or 3. Okay. First thing. If we think about where a maximum happens, it's where its derivative is what? 0, or it's undefined. So there's one place it can happen. The maximum values, the extreme values of my function, will happen when or at the critical numbers. There's my first option. Now, really, really important, I'm gonna sound like a broken record as we do this. How does one obtain critical numbers? set the derivative equal to 0, or Ava said the root of the derivative I'm okay with. Okay, that's one place, the critical numbers, that's one option. Now, if you consider an interval, and I don't want you guys to sketch this, I just want you to help me pick out how we want to word it. Let's say I have a closed interval from A to B. And it does this.
Do we have to draw that?
Nope. Okay, there's a critical number right here. Why? Yeah, the derivative would be 0. The slope of the line that's tangent is 0. There's a critical number right here. Okay. Were either of those the absolute or the global extrema, though? They're local, but are they the absolute or the extreme values?
We don't know
No.
because the line.
No, I'll tell you. That I can see very clearly that this is not the global max. Where does the global max happen?
Up there.
But you don't know that because the
To the left.
because it doesn't continue.
But it's only defined on A to B. So,
So we're not technically.
so this would be the global max,
I thought it has to have a point to the other side.
only to be local. Local, you need to be able to compare it to his friends. Global, just compare it to everything else in the set.
Oh.
Okay, so here's the decision that I was kind of struggling with. If I found these critical numbers, I still haven't found my extremes, right? I also have to check the whats, the ends. So I'm going to put endpoints. Does it make sense to say 2 places where it's critical numbers and endpoints? Or should I say 3 and say 3 places, critical numbers, left endpoint, right endpoint?
Endpoint.
Just endpoints? Okay. 2 places. We either need to find, it'll happen at the critical numbers, or it'll happen at the endpoints. Which in this particular function, or definition, it's A and B. Okay. Let's find some mins and maxes. You guys need a second to write it down. So here we go. This problem might take a little while. Example. I want to find global extrema. Oh man, this stuff is so cool. Does it feel okay so far? Okay. Here we go. For our first one, I want to deal with the function f of x is equal to 2x cubed minus 3x squared minus 12x plus 8. And we are going to be working very specifically on the closed interval from -2 to 3. All right. Now, if you guys think all the way back, do you remember dealing with extrema in algebra? A little bit, pre-calc. It's where you would graph it and you would just look at the graph and see where it happens. Now, we're going to be able to find these without ever having to look at the graph. I don't have to build a table and look and see when it starts to rise and fall. Nothing goes on. The derivative is going to tell us all of that information purely from our critical numbers. Now, let's find the critical numbers first. Okay, and I'm going to put the little steps in here. 1, find critical numbers. To begin finding critical numbers, what do? I need to get back in the habit of calling on random people in here. Aldrin, we're making eye contact though. What do you want to do? Let's find the derivative. Sugar, help me find the derivative. F prime of x is
6x squared. Subtract 6x. Subtract 12.
perfect. Love it. All right, now we'll get some random numbers going. I did not take attendance and Sam's not here. How many people are in here normally? 3, 6, 10? Okay. I'll be 11 even, I'll tell you that. 10! Jerwin, what are you going to do now? Like, walk us through little steps.
Set the derivative 0.
Okay. Do you want me to rewrite this exactly as is, or is there something you'd see you would do?
I would factor out 6.
Good choice. x squared minus x minus 2. Okay. Now, notice that this is just included in finding the critical numbers, right? Find the first derivative. We got it. Set it equal to 0. We're going to have our critical numbers. I'm just making us do a little algebra review real quick. Number 2, Ava, I'm going to divide each side by 6 just real quick. How would you have me solve this then?
X minus 2. X plus 1.
How on earth did you do that so fast? Yeah, Ava knows how to factor with the shortcut. Does everybody still cool with factoring with the shortcut?
Why did you take out the 6?
Because dividing by 6 made it nicer. Factors of negative 2 that add up to negative 1. Try it again. Negative 2 and 1. Because my leading coefficient was 1, here's negative 2 and 1. Okay, check this out. I'm going to be a huge jerk. What do we call the zeros of the derivative? Critical numbers. Somebody else was right. I need to have you see critical numbers. X equals, what are they? 2 and negative 1. Okay, we have found our critical numbers. If we read through that theorem that we just saw, we said, given some function f, the extrema or the global extrema will occur at the critical numbers or the where? The endpoints. Now, here's a spot where everybody gets mixed up. I'm trying to find the global extrema of a function f, right? Everybody okay with that? I'm asking you, hey, where are the extremes of f? We've been dealing with what right now, though, in yellow? I've been using f prime. I don't care about f prime other than it gives me my critical numbers. What I'm going to do now is I'm going to check, and I'm going to make sure this is really clear. 2, check the critical numbers in the, and I'm going to capitalize this, original function. And I'm going to sneak something in parentheses here as well. We need to check the critical numbers in the original function. That's what I'm actually asking about. The mins and maxes of f, not f prime. But I need to check the critical numbers. And where else could the extrema occur? And endpoints. Okay. Now, traditionally, there's a bunch of different ways we can do this. I think it makes sense to use a table. I'm going to make a table of x and f of x. Again, I want to really highlight f is the original, right? Okay. Here we go. What's the first value of x that we would include thinking about both my endpoints and the critical numbers? Negative 2. That's my endpoint. Okay, then I would hit what on my critical number? Negative 1. It's my next critical number. Then I would hit what?
2.
And I'd finally hit 3. Cool. I have a pretty good feeling that, not a pretty good feeling, I guarantee that one of my global maxima, or all my global maxima, will be seen in this list. Do you want to do it by hand, or can you just type it in your calculator?
Which one?
This f of x part. Do you guys know how to type this into your calculator? Yeah. Do you? On the 89? No. Okay, go to y equals. I think it's diamond top left. Do your calculator, Adrian? Mine's here somewhere.
Oh, I still need to return to school.
Please do. Okay, diamond top left. Type in this function. 2x cubed minus 3x squared minus 12x plus 8, because again we're plugging in the original. Type this function into y1, the green one.
X to the third minus 3.
You have to use caret on your calculator. It does not have a nice x squared button. And I'll turn it back off afterward, but I know the screens are hard to see.
And then do you press
Makes it
graph?
easier to see this one, but harder to see that.
Yeah. So when I teach on my other classes, don't grab it, Adrian. You have two options. You can either go to your table, which I'm going to talk really loud next to you.
Oh, I got the table.
Because it's diamond F5. Now you can check the table, or if you go back to your home screen, it's as easy as just saying y1 of, and you can type in your values. Okay, don't care which ones you use, but somebody tell me, what do I get at -2?
-2, you get 4.
Somebody second that, it's 4? Okay, how about a -1? 15. At 2?
-5.
Ooh, disagreement.
What? 2 at -12. Okay, I was looking at
-12, and at 3? -1. Okay, from this table, notice we haven't thought at all about the graph of f of x yet. Like, we haven't really thought about what it would look like. Is there anybody who needs help getting these numbers out of your calculator? There's something stuck on that screen. Get out of there. I might. Everybody get these numbers. Can you tell where the minimum is? The absolute minimum. At 2. Okay, so check it out. We're going to write our comment here. F has, do you want me to call it a absolute or global? Okay, I'm going to say, yep, sure, I'm fine with that. Global max. Do we do max first or min first? We did min. F has a global min at 2 -12 and a global max where? -1, 15. Okay. Cool. Let's check it out real quick. Haven't really thought anything about the graph. Didn't have to graph F, didn't want to graph F. Well, somebody, you need that back, B? Okay, here in a second I'm going to need somebody to read me this function.
2x cubed.
Yep, nope, give me a second because I'm going to type it in Desmos. All right,
2x cubed.
2x cubed.
Then a minus 3x squared. Subtracting 12x. Adding 8.
Okay, and we're working on what interval?
2, -2, 3.
Okay. Here's the graph of this function on that interval. Here's what it looks like. Okay, looking at this, we found that the maximum happened. Do you guys agree now this is the absolute max? And check it out. That is the point -115.
Awesome.
That's what we found, right?
Yes.
I think this looks like the global min here. And we found it. Now, what we want to make sure that's kind of seeping in the back of our heads here. I found 2. Dang it. See what's happened. The critical numbers that I found, they were both extrema. Maybe it won't always happen that way, though. Okay. Another one together? You want to try one on your own? On your own. Okay. Ooh. Kind of love this problem. Okay, I want you guys to talk this out with one another. You guys like throwback problems? Cool. Notice, f of x, I'm not doing this to be annoying. I'm writing it there intentionally. F of x is 2x minus 1 if it is a piecewise, it's 2. -1 is less than or equal to x is less than 1. Or it's -x squared plus 2. If x is greater than or equal to 1 and less than or equal to 2. Well, here's your chance to kind of rekindle what could have been. Or possible love now that you've both had time to grow. Okay. Looking at this thing. Somebody find me the extreme value theorem real quick. Or tell me what it says if you remember. The extreme value theorem. If it's what? Is it?
No. Yes.
How do you know?
We don't know.
Oh my gosh, if you want it to be continuous, I think you better show me that as you come from the left and you come from the right, you fill it in and everything's all right. Okay. Yeah. Got bars for days. Okay. I need you guys to do the limit as x approaches what value of x? Where does it get weird? 1. Take the limit from the left and the limit from the right and f of 1 to verify it's continuous. If the function is continuous, you can then apply the extreme value theorem. Cool. I'll give you guys a little bit of time. Chat it out with one another. If you need help with limits, let me know, and I'll help you with limit. Okay, so we're going to talk about this first.
Okay, I got 1 for as x approaches to the left.
Okay, Jadri claims that when she writes a limit as x approaches 1 from the left of f of x. If we're approaching 1 from the left side, which function would you use, Shane? I would agree. Direct sub, what do you get?
1.
2 minus 1 is, 1. I agree, Jadri. Okay. I'm going to put a question mark. Not yet. We need to make sure before we try to use that theorem, Chanel, we need to make sure that it's continuous. Lily, if I were to approach from the right, what would I plug in? Which function? I'm sorry. Negative 1 plus 2 is 1. Am I certain it's continuous yet? No, it's a good sign. F of 1 we also need. Which function would you use if I'm actually evaluating f of 1? Not both. Just less than or equal to. We use the bottom.
Negative 1 squared, negative 1 times negative 1 is
Nope.
1.
What happens first, the exponent or the multiply? So 1 squared, and then we multiply by negative. F of 1, I use the bottom function because or equal to, it's also 1. Is this continuous? Yes. Since it's continuous, stuff applies. You need to take the derivative, f prime of x, in pieces. Take the derivative at the top, take the derivative at the bottom. Our bounds stay the same. Oops. Cool. All right. Here's my original function. Because things got a little bit weird in here, I assume. Well, what did you get for critical numbers, out of curiosity? So you shouldn't get 2 different critical numbers. Everybody probably got x equals 0. Okay. Now, I think that this is reasonable to think about. I'm going to tell you it's wrong, but I really want to address why it's wrong. Like, don't erase it. Let's just think about it. Which derivative did that value come from? The second one. What interval did we use for the second derivative?
Oh.
Go ahead, Rihanna. You're right. 1 to 2. Is this in that interval? No. Check it out. Don't get rid of it. Not in the interval. So although it is a critical number of that function, it isn't where we're caring about it. Okay. We're going to dig way back now. A derivative can be undefined at this place. A sharp corner. Are there other ways to draw sharp corners? Like, it can be smooth on one side and then poke you like that, right? Did you guys talk? I don't remember if it was me. Do you remember talking about how derivatives can do this and be not the same from both sides? And then, do you remember the last one? The cusp. It is this one. However you want to do it. Yeah. Okay, the cusp. Now, looking at this, I have a derivative right here. Is there anywhere that you might be concerned with it, I don't know, being different? Like, where would things possibly get wonky here? At 1, right? That's where we have to join things together nicely. Gosh. What's f prime of 1? I'm going to make that comment. Things might get weird at x equal 1 again. Things might get weird. That's really formal language. There's an R there, I promise. X equals 1 again. What's f prime of 1 from the left? I'll write it out. What's the limit as x approaches 1 from the left of f prime? It's not 1. From the left, it's 2. Because if I want to know the limit, I'm just going to direct sub. As I come from the left side, I use the top function. I think it's 2. What about the right? The limit as x approaches 1 from the right of f prime of x. Shaw, you're right. It is -2. Do they match? Ooh, my derivative didn't match. It's not continuous there. It's not defined there. Where's my real critical number? What x value to get weird at? 1. Now, if I go back to my graph, I can see it happens at 1. This is where things get all wonky, right here, because I see a sharp turn trying to happen. Now, we're not almost done with the question. I don't think I'm going to give you guys a bunch of piecewise. I just wanted to address it together here. What was I actually asked to do? I need to find the min and max of the original function, right? So here we go. Here's x and f of x. What's the furthest left point you might plug in to check? Why -1, Jerwin? It's the end point. We go from -1, and when we plug into my function f, what does it give me? -3, right?
Yeah.
And then what's the critical number I found? 1. And when I plug that in, I think I get 1. And 2 is the other endpoint? And when I plug in 2, I'm pretty sure I get -2. Where were the extrema of f? And I'm going to shorthand this. F has, where's the global max? 1, 1. Okay, homework, I have no issue with shorthanding it like this. Be as concise as you possibly can. Where's the global min? Perfect. -1, -3. Cool. And we have it. I just want to, really reaffirm this. This is where people get goofed up. You plug back into f. Okay, how do you find a critical number?
Take the derivative and then set it equal to 0.
You take the derivative and set it equal to 0. I love it. This was 4.2. Have we done a homework from 4.2 yet? Why is this homework so short?
Let's do it.
Time.
Oh.
It was me taking a timeout so I could look at what I want to give you guys. But I'll take that too. It landed. My sister-in-law made it. All right. It's been so long since I've given you guys homework. It's been so long since I put it on Google Classroom. Okay, so this is, what's today?
Today is
Thank you.
December 13th.
Okay, this is going to be homework. Man, this might be too short. 4.2.1, we'll find this on page 298. You guys get to do 7 through 12. This is due tomorrow. I bet I take it tomorrow.
Did we turn in this 13,
That's
23,
it?
24?
Yep.
I bet you won't. Oh. I bet you won't.
We turned that in?
No, we did those together. We're a little behind, but we're going to get caught up, I promise.
Mr. Hallway, can I see my test?
How much money you got?